So in this video, I'm going to go ahead and point out a really common mistake that infuriates me, okay? And show why my generic rectangle method is, well, it's not mine, but the one I tend to use works real well. So first off, let's go ahead and talk about the fact that this is not equal to 2x squared minus 1, or let's say plus -1 squared. You can't distribute this exponent, okay? Again, if we go to that idea, what is our base here? Our base is 2x minus 1. So that means that this must equal 2x minus 1 times 2x minus 1. We've got two of our bases based off of the exponent there, right? Okay, well, now that we've gotten that out of the way, let's look at something that would be a little challenging to do using FOIL. So we've got 2x, let's say, squared minus 4x plus 3. And let's say we're going to square that. Whoa, well, that makes things a little complicated. Well, we do know, though, that the base here is just the piece inside the parentheses. So I know that I have 2x squared minus 4x plus 3, and I have two of them. Okay, but now I have to multiply these out. Now, you can kind of FOIL this, but I really like, again, my generic rectangle method. Once again, it's not actually mine, okay? But for each of these here, I'm going to need 3 sections. And it's the same, but I still need 3 sections for this as well. Okay. Now I just have a bunch of simple things to multiply out. Okay. And you can just go through. I'm going to do it row by row. 2x squared times 2x squared, 4x to the 4th, 2x squared times -4x. It's going to be -8x to the 3rd. And 2x squared times 3 is going to be 6x squared. And you can go through and populate everything else using the same method. Okay. And one of the things that I really like about this is if I want to, I can go back and I can just check my work. I can recheck the boxes and make sure everything's added up well. Also, what's really nice about it is the diagonals, and there are some instances where this won't happen, but the diagonals are like terms. So I've got my first term here is just 4x to the 4th. Then I have this diagonal here, where those are both cubes, so I can add them up. I've got -16 of those x cubed, and I just go through and add all these up. And I'm all done. And again, the benefit of this is if I made a simple error somewhere, it makes it really easy to go back and find that error. Organization makes mathematics way easier.